Combustion reactions is our next topic. We're looking at combustion always symbolizes burning. So we're going to basically look at burning reactions, and we'll do some of these in the lab as well. So let's look at a definition of a combustion reaction. Hopefully, again, this is a bit of review. This describes a chemical reaction in which substances react with oxygen. Okay, that's the big key, producing heat and light. And what it does is it produces the most common oxides of whatever element is being burned. So for example, if I'm burning carbon, I'm going to make carbon dioxide. That's the most common oxide of carbon. If I burn hydrogen, I'm going to make water. That's the most common oxide of hydrogen. Sulfur makes sulfur dioxide, and nitrogen makes nitrogen dioxide. Okay, so that's sort of important because that will help you when we're predicting some of these reactions. There's sort of two different types of combustion reactions that you need to know about. The first is a complete combustion reaction. So complete basically means you have a sufficient or lots of oxygen. Really common example of this is hydrocarbons that react with oxygen to produce water, vapor, and carbon dioxide. So hydrocarbons, that might be sort of a new term for you. So if we take a look at that, it basically explains what it is just by looking at the name. So we've got carbon in it, so that means it's made up of carbon, and hydro stands in this case for hydrogen. So we have a compound that is made up of purely carbon and hydrogen. So here's an example there, is C8H18, that's my hydrocarbon. And when I react it with oxygen, I always make water here and carbon dioxide gas, okay? The reason I can make my carbon dioxide gas is because, again, I have lots and lots and lots of oxygen, so I can put 2 oxygens on every carbon that I have in my reaction. This I know you guys have seen before, and we shouldn't even say really global warming anymore. We should call this more climate change. But anyways, you guys have all heard that the carbon dioxide emissions from a lot of the human activities that we do, such as running our cars and heating our homes and all that, is contributing to climate change. So just thought I'd bring that up because that's probably going to be part of your unit project. Okay, incomplete combustion means that there is insufficient oxygen supply. So I don't have a lot of oxygen, I have only a little bit of oxygen. Only a little bit of O2, okay? So what ends up happening is I don't have enough to put 2 oxygens on every carbon. So sometimes I only end up putting 1 oxygen atom on every carbon. So when that happens, we end up still producing water. We produce carbon dioxide, but plus we're also going to produce carbon monoxide, which you have all heard of before, I hope, or we could even just produce straight carbon. So carbon monoxide is a colorless, odorless, and very poisonous gas. And symptoms of carbon monoxide poisoning, if you've heard of that, are headaches, fatigue, and eventually unconsciousness and death if you're not treated quickly. So it is sort of a really serious situation to have carbon monoxide poisoning. So let's look at a little bit why that happens. Here is complete combustion of, again, a hydrocarbon. In this case, this is octane. So again, it reacts with oxygen, so I know it's a combustion reaction. It makes carbon dioxide and water. Check. Okay, great. I've got tons and tons and tons of excess oxygen, so I can put 2 oxygen atoms there and 1 oxygen atom there and make my most common oxides, and I'm happy, and that's the end of that. In incomplete combustion, I'm lacking a little bit of oxygen. So that means I don't have enough oxygen to make only carbon dioxide and water. So what ends up happening, instead of making carbon dioxide, I make some carbon monoxide because I only need to put 1 oxygen atom on that carbon. So that gets really dangerous, again, because we know carbon monoxide is a toxic gas. So, oh dear, let's get rid of that rating. There we go. So if we have a look at this slide really quickly, I just wanted to talk to you about this because I would like to make this your unit project, looking at combustion in the atmosphere. You've all heard of the greenhouse effect, which is the theory stating that heat is trapped near Earth's surface by carbon dioxide gas, atmospheric water vapor, and some other gases. And so if we're increasing the carbon dioxide concentration in our atmosphere, we are contributing to keeping heat closer to the Earth instead of letting it go, and that's contributing to climate change. So we're going to talk a little bit about this later on, and we will basically do a project on that later. Now what I'd like to do is look at a few examples. So here's what you're going to be required to do. A, you're going to have to recognize whether or not something is a combustion reaction. So if I do something like C3H8, which is propane, which is stuff that will fuel your barbecue, and I put O2, you have to tell me what it will make. So your answer should always be a complete combustion reaction unless I give you some more information. So sometimes I will say, okay, you're going to just have a complete combustion reaction, predict your products, and you do CO2 plus H2O, done. Sometimes you'll see some questions where it says, okay, you've got, say, butane, which is C4H10. You don't need to know that, but that's what's in your butane lighters that you can, say, buy at a gas station. And if you burn that in oxygen, let's say we make equal amounts of carbon dioxide and carbon monoxide. So I would have to tell you that in the question in order for you to be able to predict the products and balance the equation. So if I have CO2 and CO and H2O, then you'd have to balance this to make sure you have equal amounts of carbon dioxide and carbon monoxide, because that's what I would have told you in the question. So whenever you're doing reactions about this, and sorry, I haven't finished balancing the whole thing. I probably should, because that will make the rest of my video actually viable here. So let's see, I've got my 4 carbons on both sides. I just balanced for my hydrogens. So now I have oxygens. I've got 5 plus 2 is 7 plus another 4 is 11. So I can do 11 over 2 for my oxygens there. Or you could double everything up if you wanted to. So for this, again, they're trickier to do. You have to be able to recognize a combustion reaction by recognizing that something's burning in oxygen. And then you have to be able to predict the products based on additional information that I give you. So I'll either have to tell you nothing, in which case I would accept sort of both answers. They would both be correct. Or if I'm a little bit specific, then you just need to follow those directions. So we'll practice those in class, and we'll go from there.